Hello everyone, my name is Angel Israel Vasquez Acosta, and today I will be talking about deep water drilling. Let's start a mobile offshore drilling. Now, we have marine drilling units. For example, types of drilling units. We have fixed units, mobile units, for example, submersibles, jackups, semi-submersibles, drill ships, TLP, SPAR platforms. The second factor for choosing the right unit, we have will deep, water deep, availability, safe type, recurrent mobility, environmental conditions, and with Jacob rigs, we have operate in depths up to 19 meters. Can we have waves of 6 to 9 meters and winds greater than 120 kilometers per hour, and designed with 3 or 4 legs. 4 legs units are more expensive and less practice in deep water. Semi-submersible rigs operate in water depths greater than 100 meters, is stabilized by bonds and anchors, capable of withstanding severe and sea conditions. Next, we have a semi-submersible platform with another system. We have the development of submersibles, development from submersible units. The first unit was introduced in 1961. Design features: typical, we have 3 or 4 legs on each side. Legs are connected by frontons that store water for partial submersion. Third, operational conditions. Designed for open sea operation, can operate in deep water with strong winds and severe wave conditions. 40, model variation. Some never designs feature triangular hulls, multi-hulls, or fringe pentagon designs. Designs provide shape, stability, and symmetry. Okay, let's continue. Next, we have dynamic positions platforms. When drilling at extreme depths, traditional anchoring is not enough. That's where dynamic position platforms come in. They use computer control to stay precisely over the well without anchors. This achieved through signs sent from the sense floor to satellite and back to platform. This system provides high accuracy even with strong currents or changing winds, which is essentially in waters deep than more meters. And the next, we have relevant oceanographic parameters. We have designs and operation offshore platforms directly depend on factors such as waves, their height, variety, and direction, generate dynamic loads on structure, ocean recurrents. They affect the stability of risers and anchor lines, tides. They vary the sea level and influence to the tension of the riser. Winds. They affect the balance and movement of floating platforms. The mooring system must be calculated based on these parameters. For example, in Gulf of Mexico, wave heights of up to 10 meters have been recorded during the tropical storms. Boreals and real-time sensors are used to monitor oceanographic conditions during the operations. The next, we have SUB's Christmas tree system. The ship well is fundamental in the structure of an offshore well. Sits on the ship and serves to give support and syndication string. Many components included to give base, hanger sails, and connectors. Manufacturing like Cooper Cameron, ABB, Vector Gray, and PMC offers incentive. For example, the Sub Christmas tree is a set of equipment installed on the ship dock to support, give, and seal the casing pipe. Many components, the first, permanent gate base, it orients to tools during the drilling. Pipette hangers, they allow pipes to be suspended at different depths. Seals, they can be elastomatic, metal to metal, or combined. Valves and connection for controlling pressure and connecting the ship tree. Most commonly used system Cooper Cameron, ABB Vector Gray, PMC. The installation is carried out with hydraulic tools from the surface, and differential pressure tests are performed to bind to seal. The next, we have sub wheel planing. With sub planing, recreate compressive visions. It begins with collection oceanographic and geologic data. Then overburn presumed is calculated using the Ayton equation, and fracture gradient is estimated using B. Ayton. In this part, that collection, bimetry, severe types, wind, tides, and currents. Fracture gradient estimado using B. Ayton formula to avoid formation fracture during the cementing. Pipeline statement design is considered pressure profiles and gradients to select the appropriate diamonds and materials. E-plating also includes from foundation design, structural annihilation on wellhead, and estimation of abnormal pressure or shallow flows. The next, we have unconventional tools and cementing. Deep water operation requires special tools such as a motion, compensator, marine race, and tension. This helps minimize the effect of platform moment on drilling. Cementing is another major change due to low temperature and high pressures. Solution include nitrogen and enzyme to cement to improve and without increasing the science and special activities to accelerate setting in cold environments. They ensure the wheel is security safe. The motion compensator decides that absorb the vertical momentum of the platform due to waves, protecting the integrity of the drilling equipment. Marine racers pipes the contact the platform to subswing along the circulation of fluids and tools. Sensors systems that maintain the proper tension in the riser to compensate for platform movement, and with lines, cables to facilitate the installation and retrieval of sub-equipment. Cement in deep waters face challenges such as shallow flows, fluid movements in a shallow formation that might compromise the integrity of the well, high pressures that require special cements capable of while studying extreme conditions, thermal conditions, low temperatures that affect cement setting. Solution, we have two. The first, use nitrogenol cements to improve strength and reduce density. Two, application for additives to accelerate setting in a cold environment. The second, we have load control. We have control. We have a scenario fishing strain. The pipe gets trapped in the wheel, making pressure control difficult. Have or cut strength interruption in the continuity of the pipe, preventing fluid circulation. During drilling, unexpected influx on formation flows into well increasing pressure. Consequences: loss of well control, damage to casing pipe, significant environmental risk. Control measures: installation of the sub-blow preventers, BOP, continuous monitoring of pressures and volumes, implementations of rapid closure procedures in case of low detection, and finally, storage image. Next. The next, we have subsea control system. We have types of control system. First, direct hydraulic. Use hydraulic lines from the surface to operate subsea valves. Second, hydraulic with piloted valves. Incorporates valves that allow control of multiple positions with fiber lines. The third, electric hydraulic, combines electrical signal and hydraulic power to operate subsea equipment. A multiplexer allows of control of multiple functions through a reduced number of electric lines, improving efficiency and reducing the umbilical weight. Advantage of the multiplexer system: faster signal transmission, reduced number of required lines, better diagnostic and real-time monitoring capability. The next, we have operation and comparison of control systems. Risers are tubular systems that connect the well on the seabed to the floating units. Types: drilling, single stream with hydraulic control, limited access, low cost. Completion and repair allow free access to holes and annual for the sub-drill. Classification: not integrate, separate strings for production of drilling, joined with conventional connection. Integral, pressurized conduction joined to in common assemblies, includes a clay risers to wasting high loads, and design conditions, water depth, axial stress, hydraulic control, vibrations, and fatigue. The next, we have drilling, completion, and repair risers. Risers analysis includes static analysis, tension under self-weight and internal pressure, dynamic analysis, response to waves, currents, and platform moments, fatigue analysis, operational life-based analog cycles, common components, ABB and Cameron, telescopic joint, flexible joint, gimbal, tension rings, keel and choke lines, head and BOP equipment. Difference between Cameron and Vector. Cameron does not include a flow generator or motion compensator. Vector includes both and manufactures the complement system. Uh, Next, we have design and analysis of risers. Substrate structure that control the flow of production or internet well. Types vertical and horizontal. Vertical is like simple control in complementation with lines, and horizontal allows better access with lines, ideal for deep water. Components, connector, gate valves, actuator, choke, tree cap, protective frame, and installation with the specific tools, for example, tree head installer, TR hanger bushing, and the testing and orientation tools. Next, completion and repair technology. Objective: to allow the well to produce hydrocarbons safely, efficiently, and in a controlled manner, optimizing its lifespan. Types of completion: we have three: substrate, tieback, and multi-line system, and bottom completion. Substrate is like vertical, horizontal, control the flow and allow interventions. Tieback and multi-line system, it's like connection between the substrate and the surface. And bottom completions includes hanger, backers, safety valves, and sensor. Technology use: hydraulic or mechanical solution, metal or elastomeric seal assembly, electro-hydraulic multiple control system. Okay. The next, we have pipe hanger system. Main function system. Main function: to support the production pipe and isolated areas of the wheel truck seals. Types of hangers: we have two: parallel, concentric. Parallel allow multiple flows, and concentric more compact, ideal for system. Key elements: orientation method: ensure proper alignment of the hanger in the tree head. Installation method can be hydraulic or mechanic. Cell types: laser metal, combined, select, based on pressure and temperature. Special options: annular seal test report, safety valves, pressure and temperature reduction, and anti-rotation system. Operation tools: LED printers, lifting and orientation teeth tools, pre-rushing, washing. The next and finally the exposition, conclusion and recommendations. Conclusion: the first, deep water completions require a specialized solution due to their technical complexity. Second, proper designs and installation of hangers and completion systems directly impacting operational safety. Third, the interaction between the riser, motion, compressor, and substrate is essential for the system safety. A recommendation: choose the appropriate substrate hanger type, considering water depth and well conditions. Apply hydraulic installation methods and depth greater than 16 from greater reliability. Perform periodic maintenance of subsystem to prevent failures. Finally, invest in qualified personnel and pre-gain and installation simulations. So finally, thank you. See you.